Today on Virtualize Everything, I'm going to show you how to install and do some basic setup and use a little bit Kasm workstations on a Raspberry Pi 4. And that's right, I'm going with a Raspberry Pi 4. Unfortunately, with the size of my channel and the availability of stuff to my channel, I don't have a 5. I have to wait in line like all the rest of you. So with that, let's take a look and see what it takes to start installing Kasm on a Raspberry Pi. So I'm going to actually be using an SSD here, and it's going to be a 120 gig SSD that I pulled out of one of my systems. I'm using a Samsung Evo 850, but really whatever SSD you choose and adapter you use will work just fine. Now, you're not going to be able to use an SSD like this with a Raspberry Pi 3, and I really don't suggest you use a Raspberry Pi 3 for this type of task. I also suggest that if using a Raspberry Pi 4, that you choose a minimum of a 4 gig model, with an 8 gig model being even better, as Kasm requires quite a lot of RAM, and I believe its minimum system requirements are actually 4 gigs. So the first thing you're going to need to do is download yourself a copy of the Raspberry Pi Imager tool. Now, I've already done this and I've installed it, but if you wish to use the Raspberry Pi Imager tool, you can find that at raspberrypi.com/software. So here's a view of my Raspberry Pi Imager tool installed here. And the first thing I'm going to do is choose devices, and I'm going to choose Raspberry Pi 4 as that's what we'll be using. If you have a Raspberry Pi 5 and would like to use that, feel free to choose that as well. Then I'm going to choose for an operating system, Raspberry Pi OS 64-bit edition, and I'm going to select my 850 Evo that I mentioned before. Now, with this new version of the Imager tool, I'm going to press Next, and it's going to ask me about setting up settings. I want to indeed go ahead and edit settings. Now, here at the Raspberry Pi Imager settings, you can notice that I've chosen to create a custom hostname. This is entirely up to you whether or not you want to do that, but we'll be calling ours chasm.local here. I've set up a new user account and password, and I'm choosing to use mine over wireless. It's not the best option, but unfortunately with my network gear here at the current location that I'm filming from, wireless really is the best option, as I don't have any ports available on my router and I don't have an extra switch. Then I'm going to be choosing my time zone, which for me, I'm in the New York time zone, so I'm choosing that and using a US keyboard layout. Feel free to adjust these settings as needed for your current location and keyboard layout that you prefer. Now, I'm also going to be using SSH, so I'm turning on SSH, and the Raspberry Pi Imager tool now makes it extremely easy to actually set up public keys and private keys for using RSA, so I'm chosen to run the RSA keygen utility and export that into my Raspberry Pi image at this time, so that I can just more easily interact with my Raspberry Pi in a more secure encrypted manner. For options, we can play sound, and all of these options come as default. Well, all of them come as default actually, and I'm just going to leave them checked. So I'm going to go ahead at this point, click Save, and then it's going to come up to the same screen asking me if I want to apply the OS configuration. This time I'm going to click Yes, and it's going to let me know that I'm going to entirely erase my 850 Evo, and that is fine as well, so I'm going to press Yes. Now, on some systems, you might be asked to input your system password. I'm going to do that at this point, and nothing will continue until you do if you are on one of those systems. Now the Raspberry Pi Imager tool is going to begin creating your image, now the Raspberry Pi Imager tool is going to begin creating the image, writing it to drives. I'll be back with you when this is completed to show you the next steps in the installation of Kasm on a Raspberry Pi. So now that the Raspberry Pi Imager tool has finished creating the drive, we're safe to remove it from our system. And by default, the Raspberry Pi Imager tool actually demounts the drive from the system. So all you have to do is remove it from the USB port and then connect it to your Raspberry Pi 4's USB 3 ports. I always tend to choose the top one. I don't know if it matters, but that's just my preferred preference for ports for the USB 3 connections on the Raspberry Pi 4. And then you'll be able to connect your Raspberry Pi 4 to power and let it begin its first boot up process. Now we're going to be doing this installation headless, and it's going to take a little bit of time because the Raspberry Pi 4 and Raspberry in general has evolved to the point that we no longer have to resize the boot partition or the hard drive partition of the Raspberry Pi storage in order to take full advantage of it. It does that process when it first boots. So I'll usually wait between 4 to 5 minutes for this process to finish when operating in headless configuration, and then I will try to establish an SSH connection with my Raspberry Pi. I'll be back with you when I'm ready to establish that SSH connection. Okay, so now that the Raspberry Pi has rebooted and resized its drive, it's time to start the rest of the installation process here on the Raspberry Pi. So we're going to need to establish an SSH connection, and we can do that one of two ways. The simplest way is going to be to use the local host name that we configured during the installation process, which is chasm.local. If for some reason that doesn't work, you can find the IP address of your Raspberry Pi inside of your router and replace the chasm.local with that IP address. But this command will always start out with SSH space the username that you set up during the installation process, and in our case it's going to be VE at, and then the location, whether you use the DNS name, chasm.local, or you use the IP address, it doesn't matter. We're going to press enter, and it's going to establish a connection automatically without asking a password because we chose to use an RSA key. So the first thing we're going to do to start this Kasm installation process is going to be to run a command of sudo apt update, and I'm going to string that together with a sudo apt upgrade-y so that the whole update process of the Raspberry Pi's operating system is done all at once. And this is going to take unusual between 5 to 10 minutes to complete. Sometimes it takes a little bit longer. So as this is running in the background, I'm going to go ahead and pause this video and return to you when this process is finished for more steps on installing Kasm on a Raspberry Pi. So now that the update process is finished on the Raspberry Pi's operating system, I'm going to enter the command clear to clear the terminal and refresh the screen so we can start looking at the next steps we need to do. Now, the next thing we need to do to install Kasm is actually to install Docker. Kasm runs almost entirely off of Docker, and we'll need Docker installed before we install the Kasm operating system, or Kasm server software rather. So I'm going to follow this tutorial from Raspberry Pi Tips. It uses a really convenient script that makes it quite easy for a beginner or medium novice user to install Docker with very little fuss or copying and pasting. And the commands we're going to need are right here in this section. So I'm going to copy the first one, head back to our terminal, and paste it in. Now what this command is going to do is use a software called Carl to establish a connection to a server at get.docker.com and download an SSH script which is going to do the installation process. If you're not familiar with the script, or if you would like to just view the script, you can always view the web page in order to read through the script and make sure it's safe for yourself. It's generally best practices to do so. So now that I feel that the script is safe, I'm going to go ahead, press enter, and let the installation process begin. Now, this installation process, in my experience, takes between 3 and 5 minutes. So I'll be back with you with the next step when that is completed. So Docker is finished being installed, but it's better off to add Docker, but it is better off to add the Docker user group to your user, which will give you permission to interact with Docker without having to use the sudo command every single time that you load Docker or try to interact with Docker. Although this step isn't as necessary with Kasm, later on we're going to find ourselves creating Docker containers for the next part of the evolution of our Kasm server. So this portion is fairly suggested to do. The command we're going to use to do so is called usermod. And you notice we're putting sudo in front of this because it has to be run as super user permissions or root permissions. The -ag adds the group of Docker to the user, and the $user just allows this command to automatically read the user that you're interacting with and add it to that user. So you can press enter, and that is done. Now this command won't take effect until the next time we reload our connection. This mod won't take effect until the next time we log in with this user. So a lot of times when you're installing Docker, it is suggested to, at this point, to log in and log out. We're not going to do so today, and we're going to continue on with the installation process because we don't need to interact with Docker yet. So for the next part of this installation process, we're going to follow the offline installation directions for Kasm on an ARM 64-bit system found on the Kasm website. And we'll be copying and pasting the commands from this very page for that process. The first command is going to change our directory to the temp directory. This is a great working directory for files that won't be kept after the next reboot and allows you to work without messing up the rest of your system with files such as this. Now that we're inside of the temp directory, we're going to download 3 different files. And the timeline for downloading these files is going to vary, with each file getting intensively longer to download each time. So now that all 3 of those files are downloaded, we're going to unpack one of the tarballs, which is going to contain the installation script that'll be used for installing Kasm from the other 2 files that we downloaded. And the last command we're going to be running is going to be a script, and the last command that we're running is going to be a command that executes the bash script that we unpacked with the last command using sudo, and the command is also going to specify to the script that we're using the offline installation technique and where to find the 2 other files that we downloaded that are used for the installation of Kasm. This command could take a while to run, so be ready and maybe go off and grab yourself a cup of coffee. We want to read the EULA and verify that we have fully read the EULA by pressing Y and enter. No glasses in my truck. So when Kasm's finished installing, you're going to get an output like this. This information should be saved for later, but the main thing that we need to pay attention to is these top two lines. The user account and the admin account, and more precisely, the admin account will have to be paid attention to, as we're going to use that for the first login. Now, for the first login, I'm going to push my console window out of the way, and I'm going to head over to my web browser. Create a new tab, and I'm going to load https://chasm.local. And that's going to give me a warning screen like this because Kasm's using an unsigned certificate. I'll show you about fixing that here in a little bit. Right now we're going to click Advanced and proceed to chasm.local. Now, if your system is using an IP address instead of a DNS name, you will need to replace the chasm.local with the IP address. Now to log into our admin account, we're going to copy our admin@chasm.local email address and our password. Now the first thing I want to do, now that we've logged into Kasm, is go to Access Management, Users, and click Force Password Reset on Login and save, and I'm going to do the same thing for the user. Now we can log out, use admin, and our password that was set up by default, and log in. This time we're given a password reset screen, and we can enter our own password and hit submit. And for this login, we'll now use our password. And we've logged into Kasm. So you can imagine the steps repeating themselves that we just took for the user account. And now it's going to be time to sign off and go on to the next steps where we use Cloudflare to set up a tunnel inside of our Kasm server so we can access our Kasm server anywhere in the world via the internet safely and securely with a Cloudflare Zero Trust tunnel. So for the next part of exposing your Kasm server to the web using Cloudflare tunnels, you're going to have to log into Cloudflare and set yourself up an account, as well as have a domain name that has been transferred to Cloudflare's DNS service. Once you have done that, you can navigate to their Zero Trust panel, and under Access, you can select Add a Tunnel, just as I'm doing right here. Now, for tunnels, you can give it a name. This can be a unique name and whatever you would like to call it. Now here at this window, let's select Docker and copy this line. Now let's bring our terminal window back up and copy and paste the command that was given to us by Cloudflare into the command line and execute it to make sure everything's working correctly. So we got an error message due to the fact that we never logged out and logged back in to our session when we set Docker up originally. So let's go ahead and do that right now by typing exit and then reestablishing our SSH connection. Now we should be able to paste that command again this time and execute it. Docker's pulling down the file from Docker Hub and it'll start momentarily. Now at this point, it is started, and if we close out our terminal window and head back to the Cloudflare webpage, you can see that we have indeed connected. So we can continue on with the rest of this setup by hitting next. And now we need to fill out the address at which we're going to communicate with the Cloudflare system when we try to log into our Kasm server. Now there's a bunch of information here, and we're going to kind of do this in reverse. Let's fill out services first, and it's going to be HTTPS, and then it's going to be the IP address of our server or the DNS name of our server. And under subdomains, we're going to choose to use a subdomain rather than a path, because if we choose a path, it's going to interfere with the process of the pages that Kasm uses to create as you navigate through the Kasm web server. You will also need to fill out your domain. Right here in present, I'm not going to fill one out. Now we're going to hit Additional Application Settings, TLS, scroll down to No TLS Verification, and click that. That's because our Kasm server is using a unsigned certificate, and TLS verification will fail because of that unsigned certificate. Now we can save the tunnel, and we see everything set up and running, and it's nice and healthy. So if we create a new tab and we enter the URL at which we created in Cloudflare and press enter, we'll now be able to log into the Chasm web interface using our newly created URL from anywhere in the world. Chasm comes preloaded with a few different applications or workspaces, as Kasm refers to it, but they might be useful. They're not always the best use case scenario. And we're able to build custom ones, and we'll talk about that a little bit later in the video. But let's look at how, as an admin, we can load some of the other pre-created Chasm workspaces for our users to enjoy. So up here at our admin tab, if we click on it, we get a window that looks like this. And selecting workspaces, and then if we select workspaces again, we can go ahead and see some of the ones that are already installed. And as you can see here, I've installed a few of my own already that don't come default installed, as I explored a little bit prior to the creation of this video. We can click add up here, and we can add some of our own. But this isn't the easiest way to add workspaces to Chasm. It's actually to click here on registry. And once we click on registry, it's going to do a quick update for all the available workspaces from Chasm for us to view and download and install just by a click of a button. So as we look here, you can see that there's a bunch bright, and then as we come to the bottom, there's a bunch that are dim. If we were on an AMD 64 system or x86 system, you would find that these may also be bright and able to be used. But since we're on an ARM system, we're limited with the amount of that we can use to these that are up here. Now, if we were to select one that we wanted to explore, try out, and work with, say Debian Bookworm, and we wanted to install it, we'd simply click on it and then press install, and the installation process will begin. Coming back here to workspaces, we notice that it doesn't show up yet, and I'll be back with you in the moment when it does to show you about using it for the first time. Okay, so we're back here at the registry and the download has finished. You can tell that by the purple line having disappeared and fully turned to green right up here in this pie graph that shows the remaining storage on your Chasm server. So if we click over here to workspaces, you'll also see there's no red exclamation point in this corner here. And I failed to show it to you when we started the download, but it would be there if this was downloading. So we're actually ready to start using the Debian Bookworm image that we downloaded here as we learn to install the pre-configured workspaces from Chasm Web. So now when we click on it, we're asked how we want to open the session. And we can do it in the current tab, a new tab, or a new window. I prefer to do it in the current tab, so I'm going to leave that as the default and click Launch Session. Now here you can see Debian Bookworm loaded up fully, and it's still inside of the web browser. We can interact with it just like it's Debian Bookworm using the Applications menu over here, or some of the shortcuts provided to us on the desktop. We can also configure Chasm a little bit more by clicking on this caret icon, which brings over a window where we can interact with the clipboard, sound, microphone, and even the streaming quality can be adjusted. You can also share your instances with other Chasm users, as well as full screen options and the workspaces option, which will allow you to come back to workspaces. Now, depending on the resources in your server, you may or may not be able to activate a second workspace at this time, as I just did. So now when I go back to workspaces this time, you'll see both of them here in the left-hand side. If we'd like to close them out and remove them, we can just click on the three dots here. We can pause, stop, or delete. We're going to delete ours. Or we can click resume, which is going to allow us to reestablish the connection with our Docker container and work with it some more. When we're finished working with this container or this workspace, all we have to do is click on the caret and delete the session and delete the session. And we're back to the Kasm's workspaces homepage, where we can choose our next tool and go off on our next mission. You don't just have to create or use workspaces that are made by Chasm. You can actually take Chasm's workspaces that have the software needed to stream the desktop built in, and you can tweak them and modify them so they have your own flavor and your own stuff. So right here, you're looking at one that I created where I installed Maltego, an OSINT tool, on top of the Ubuntu Focal desktop. And I did that because we're doing this on an ARM64, and I wanted Maltego, but the Maltego Kasm image isn't supported via the ARM64 platform at this time through Kasm. So in order to have that, I needed to configure the installation. And we can start this up so you can see it works right here. And going to applications and other, here's Maltego, and we'll start it up. And there's Maltego running inside of a Kasm. So with that, let's go ahead and delete this session, head over to terminal here, and take a look at how this was done. Now, I really like to have the terminal this size so that the files can be displayed. I hope you can read this okay. I'm sorry if you can't. So the first thing I did here was to create a file called Kasm images, and this file doesn't necessarily need to be called Kasm images. It can be called Maltego. It could be called whatever you want. But inside of this file, I have two things, and only one of them we really care about, and that's the Docker file. So let's go ahead, open up that Docker file here, and we're going to open up the Docker file with Nano so we can edit it. In this case, we're going to view it, but normally we would edit it. And you can see the first part is information that was provided to us from Kasm about how to build images. And all I did was copy and paste that in from the Kasm website. Then is the custom container configuration for installing Maltego. And here for Maltego, the first thing I did was to update the container. That's pretty standard Linux process. Then I needed to install Maltego's dependencies, both Java and XDG. And that's what we did here, just using the run command. Now I'm switching to the temp directory, and I'm actually going to download the Maltego deb file. And then once that's fully downloaded, still inside of the temp folder, I'm actually going to run the installation process. And then this file's finished off finally by the ending configuration from Kasm. So the start and end of this file is the pre-configured dependencies and requirements for the Kasm workspace itself, and the middle file is our custom software that we added to this desktop. So once the file's created, we're going to go ahead and build this file. And we're going to use a Docker command called docker build. The -t specifies the file name. In our case, we're going to specify this Kasm, and then we're putting a slash because it's Maltego, and then a colon and the version number. By default, the version for Kasm or Docker is always going to be latest, but I'm specifying this as version 1 here. And then we end this up by a space and a dot. The dot just signifies that we're working in the directory that is housing our Docker file. So if our Docker file was somewhere else, we'd put the path to that Docker file. We press enter and Docker builds the file. Now I've already built this file, so it ran extremely quick. But if I was looking at Docker images, you could see that we have Kasm/Maltego version 1.1 and the old Kasm Maltego test file that was created a few minutes before that, as I did testing for this particular segment of this video. All right, so now that we have that Docker file created, we need to head back to our Chasm web interface, and you can notice that I'm in administrator mode. So I'm going to click on administrator, workspaces, and workspaces again. Now coming down here, you can see that I've already added the Ubuntu Maltego file. So I'm going to click on this caret and the pencil, and this is going to get me my configuration. If you wanted to make a new one, we'd click up here on add workspaces, and we are given a blank file here. So we want to do a container where we can use a registry entry to kind of fill this out since we built upon Ubuntu. So let's start out by just typing Kasm web, and then we're going to do a slash, and we can start typing Ubuntu, and Ubuntu is going to show up. Let's choose the focal desktop. Our friendly name, let's enter this to VE Maltego. Little description, our thumbnail, you can change this if you want. And now for our Docker image here, we're going to enter Kasm/Maltego and then that version number so it knows to use that file that we created a minute ago. Everything else can be left the same because it came in from the registry. If you did want persistent storage, you would fill that out right here, and we can save this. So now the VE Maltego file shows up, and you can notice it is using the Ubuntu logo. Here, if we go to workspaces, we can open this and we can launch our session. And with our session open, we can go to others and once again load Maltego. So I hope you enjoyed this quick session on how to build custom Kasm images for your ARM platform. Next, I want to show you how to set up pass-through of devices. And by default, Kasm allows you to pass through audio and microphones and a few other things. But you may want to pass through some different things like a gamepad or a webcam for different instances. And it's quite easy to set up that process as long as it's a default option inside of Kasm, but it's not totally intuitive how to do so. So in order to do that, we're going to go to Access Management, and then we're going to go to Groups, not Users. And one would think that you would want to configure each user, but if you try to configure this option inside of the user settings, you'll notice that you're unable to change anything. And we actually have to do it inside of Groups, and we're going to just do it to all groups for all of our users here. But if you had different user groups, you could do it there as well. And then we're going to go up here to Settings, and we can see a number of different items. Gamepad might be a good one to show you how to do this with, and by default it's disabled. And you might think, well, the checkbox would enable it. Well, it doesn't. What you have to do here is click on this caret, click on the pencil, and then turn it to true and hit submit, and notice the valued checkbox shows up. So now if we were to go to Workspaces, load Ubuntu, and open it, you'll actually find the gamepad icon that shows up here in this little window that pops up. Now you can notice I don't have a connected one, and that's due to a driver's issue. I really had tried to show you one, but unfortunately we weren't able to do that today. But that's how you add the option. You can also add options for webcams, sound, microphone, which are turned on by default. You can also disable some of this streaming and sharing and upload and download features here on this side as well. Okay, so the last thing I want to do as part of this video of Kasm on a Raspberry Pi is show you how to set up something called persistent storage. And what persistent storage is it's a way of telling Kasm how to store files that are left over in the container from the user. So if the user creates a text document or downloads maybe a cat picture, it actually shows up in the next instance. So what this looks like right here is we have an environment with no persistent storage set up right now. And if we were to open a web browser and search for, say, a cat picture and download and save that cat picture to our desktop, or anywhere else in our system, you would notice that the cat picture saved. But what's going to happen here when we finish our work day or finish our work session and come back is that cat picture is actually going to be gone. So let's simulate that by deleting this session, which is the way you close out any session here in Kasm, and restarting it. Notice the cat picture is gone. All right, so I'm going to show you how to fix this so that storage actually stays when you change sessions for each user. So we're first going to delete this session so that there's no sessions running on the server at the moment. And then we're going to go to the admin terminal and we're going to go to workspaces. Inside of workspaces, we're going to select our Ubuntu focal image and we're going to hit the over icon and edit. Then we're going to scroll down here to persistent profile path. And what this is the path where we want to store any profile content. So the content like the cat picture on our server. You want to make sure you have enough storage at whatever this path is, if it's off on a NAS or something, or however. Whatever this path is, it really doesn't matter. But here at the end, you notice that we have username in curly braces. And what that's telling Kasm is that we want to assign this to the username. In this case, this account's admin, but if we had VE or another user account here, it would create a particular folder for the Ubuntu focal image for that username to store all of their content on their profile. So we'll go ahead and save this, and then we're going to go back to workspaces and see how things change here in workspaces. The first thing we're going to notice is an added line that asks us if we want to enable or disable persistent storage for this particular user. And of course, we want it enabled, and by default, it's going to show up as enabled. So we can launch this new session with the persistent storage and see how this behaves versus the old session without persistent storage. All right, so we've now loaded into the session. Let's open Firefox, do that same search for a cat, and download the same cat picture, saving it in the same location of desktop. Now, closing out the web browser, we can see that we have our cat image right here. So this time when we delete the session and restart the session, you will notice that we still have our cat image here on the desktop, ready to be used for whichever project we wish. So with that, we're going to conclude today's video on Kasm on a Raspberry Pi server. I hope you enjoyed it and found this informational and a lot of information about how to start using Kasm at home. It's a great and powerful tool, especially for separating some of your day-to-day behaviors from your main computer, whether it's risky or not, or creating some type of virtual environment for different work, maybe on Linux versus your main operating system or whatnot. I hope you enjoyed this and you have a good night.